Hi, I'm James Nicodemus. In today's demonstration, we're going to do what's called a pasta rocket. And to do this demonstration, we have a little mason jar here, we have a noodle, some yeast, and some hydrogen peroxide. So I'm going to put some hydrogen peroxide in this bowl right here. Next, we're going to take this yeast and put that on the top there. Starting to foam up a little bit there. I'm going to light this little noodle on fire, and then we'll give this a little more of a... I found from previous attempts that it's best to get this going first. It does take, the noodles aren't particularly flammable, so it does take this a second to get going here. And once we get this going, we'll give this a little stir here, and we'll get that oxygen coming up. I'm going to zoom in on this a little bit here. There we go, there's our little rocket taking off there. You can kind of see behind there. We got oxygen coming through the... There we go. It wasn't a super huge long flame there, but kind of cool there. Get a little bit of a demonstration. In the second part of this, we'll show kind of how we do this, kind of how this whole reaction works.
So with the chemical hydrogen peroxide, it's H2O2. It's a kind of an unstable molecule, so when we it tends to want to degrade over time. That's typically why it's kept in dark bottles away from temperature. The chemical equation is 2 hydrogen peroxides will degrade into 2 waters and oxygen is gas. So down here we have the Lewis structures, or kind of a bonding structure of the hydrogen peroxides, which convert into 2 water molecules and an oxygen. One interesting thing with this experiment I found is when shaking the bottle, that as the reaction is happening, it's actually an exothermic reaction. The mason jar actually gets pretty warm while you're doing this. So the reason this works is we have the hydrogen peroxide normally will degrade slowly. It just slowly gives off its oxygen. The yeast has a material in it called catalase, which is basically a catalyst. And when we add the hydrogen peroxide and then add the catalyst, which has the catalase in it, which is the yeast, the reaction takes off quite quickly, and then that oxygen goes up through the mason jar, through that noodle, and kind of feeds that fire much more quickly than it would just slowly degrading. So when we took the reason that this begins to burn, as we said, pasta is mostly a starch, and so for all intents and purposes we said that starch is somewhat a lot of glucoses connected together. So the reaction of burning glucose, even though there's some other materials in there, but we'll say that it's mostly glucose, is 1 glucose with 6 oxygens will yield 6 carbon dioxides and 6 water vapor. So air normally is about 21% oxygen and about 78% nitrogen, with a couple of other things. So normally when we have a flame going, we're kind of limited on the amount of oxygen that's available. When we add pure oxygen through the noodle, then the process goes much more quickly. And we'll see in this next slide here. So we have a small flame where we're just getting 20% of the oxygen. When we shoot the oxygen through there, that reaction goes much more quickly, and we have a bigger flame and kind of a jet reaction. So it's kind of a neat little demonstration, and thank you for watching, and we'll see you next week.